Um, I think I think that's it, Ajay. So the stage is yours.
Nice. Thank you very much for having me back. In my previous session, where I discussed Okta workflows and OpenAI, I covered a scenario where we used OpenAI as a general text in, text out interface. The response from OpenAI's chat completion API was based on generally available information. And the scenario there was a time zone aware identity operation. Today, we will be using OpenAI to perform a summarization task. And it should operate on our data. Many of our customers have Active Directory groups that have grown over time. So they have Joe Smith, who joins the team, and his security group membership is modeled based on Bob. But over time, Joe Smith gets additional security groups. This leads to a mess. When you think about customers having Active Directory for decades and not having any governance around it, it makes the problem very challenging to figure out what the security groups represent and the pattern of users that are in that group. So the first challenge really is having no documentation on these Active Directory groups. And then there needs to be a mechanism to clean up these current group memberships so that we can move to a model where we have automation assign birthright access, and the additional are given through access requests, perhaps for just a specific period of time. It is the first challenge that we will focus on today, and we will produce documentation using Retrieval-Augmented Generative AI model, which means that we are operating on our data. The big picture is that we will generate the basic data, maybe Okta workflows can help there, of user profile attributes and the security group membership. We will take that data, chunk it up, and we will get embeddings from OpenAI, and then store those vectors in a vector database. We will use Pinecone here. The vector database allows us to store text as a series of numbers, as a vector. And given another piece of text, it is able to find which entry is similar. To understand how it does it, you have to go all the way back to high school physics. So imagine that Max and I, we walk in the same direction for a mile. The angle between us is 0. If Max decides to walk in the opposite direction, the angle between us will be 180 degrees. So there's a function of cosine that is applied to that angle to determine a number between -1 and 1, which tells us the degree of similarity. It's called the dot product in vectors. But this is the principle that you use when you're searching in a vector database. So we will perform the search, get back similar text, and then take that back to OpenAI's chat completion API, and we will get documentation. We will use Okta Identity Governance to be able to perform some cleanup, and then subsequently may regenerate documentation and have some role mining to determine what automation policies to put in for birthright access. So this is the big picture. The input data would look something like this. And when we go into the basic RAG pattern, the first part is development of the model and tuning of the hyperparameters. What is that chunk size when we look at that input data and chunk it up? What embedding to use? Do we use text-3 embedding small or large? And then the runtime is with Okta workflows, where we model a helper flow, which takes in a parameter of a group name. It runs through the process of getting the embedding from OpenAI, searching against the vector database, augmenting the query. So there's the user aspect and the system aspect. So the user role will have the base query and the text that comes from the vector database. The system content will be telling OpenAI not to hallucinate, just to operate on the data that we provide. And then it performs the summarization that could be used to generate documentation, or maybe even to augment the information that is provided as a part of the access request, so the approver has some notion of what they're approving. So there are 3 big steps. The first, we call OpenAI embedding endpoint. To get to a vector. So the output is a list of numbers, right? A vector. We take that, we search against the Pinecone database that I'm using here as a vector database, and we get the matching text. And you can see it's not exactly related to the advanced Clary group. It also has wherever Clary shows up. But we take that, and then we prepare the payload for the chat completion API. So we are telling it the instruction to base it on the data we provide. And the data we provide is both the base query as well as the data that came back from the vector search. And we go to the chat completion API, and it comes back with a summary that only pertains to the Clary advanced user group. So let's go ahead and just see this in action. So we have the base query of summarizing that advanced group. And then, as you can see, we go to the embeddings endpoint. We get back a series of numbers. So when we look at this data, right, you can see that the embedding is 1536, because that is the text embedding 3 small dimension size. We take that output, right, and we send it to the vector database, and we say, just give us the top 5, include the metadata, and then it comes back with the matches. And you can see it does have other matches as well. We take that, we prepare the payload for the call to the chat completion API. So here's where we have the search result. We also have the base query. This is our command, if you will. So telling it it's a Q&A bot, just answer it based on the information available. We send it to the chat completion API, and we get back information just on the group that we were looking for. Spend the next few minutes building this out. It may take a little longer than the allocated time, but I wanted to give you a base insight into how this model works. And as I go through building the workflow, I will show you some nuances of working with data. So the first one is construction of the base query. I'm going to model it as a helper flow so we can invoke it in various different contexts. So the base query says, summarize this particular group. We will rename this field to be base query so that we can easily identify it later. Now, the next aspect of it is we have to actually create the inputs to the embedding API endpoint. So in order to do that, I will use an object construct because it's a JSON object. We use the base query and then the model. Now the model would be the text embedding 3 small model. There are 2 models. This is a newer one, so it's the embedding 3 small, or we could have used a large model. Okay, so put that in there. The next piece is we go to the OpenAI connector, which Okta Workflows provides. This is a custom API action. And then we go ahead and put the content, the headers in. And our body is an object. So we take this object and we put it in here. Let's go ahead and save and make sure we're good so far. So as you can see, what comes out here is a vector of numbers, right? So let's go ahead now and extract that data out. So for that, we use an object get. There's a get multiple. I could use that as well, but I need only one element here. So I go ahead and I put that into the object. And the path is referenced. Okay, so we got the list of numbers at this point. So the next piece is we have to call the vector database API endpoint to search for similar content. So in order to do that, I have to construct the input. So let me go ahead and use an object construct again. So I have to tell it what are the top results that I want. Let me choose 5. I do want it to include metadata. And that is a true false type of parameter. So I'll set it to true. And then I want to be able to provide the vector. So vector, and I drag and drop this over here. So at this point, I've constructed my payload for calling the Pinecone API endpoint. So I do a post. It's the same header that is required. So I'll put that in. I don't need the query parameter here, but I do need the body and I need the endpoint here. So with this, we are going and doing that vector search. And the information that it's searching against is information that I have already put into the vector database in an index. So let's go ahead and see if we're on the right track here. OpenAI gives us the embeddings, gives us the vector. So let me go ahead and just check. Says vector invalid value. What that means is that we have not set it correctly in terms of the data type. So let's go ahead and fix that. The vector here should be a list of numbers. You notice that once I make this a list of numbers, I make this a list of numbers, it goes in the right format. A list of numbers, right? So that is very important when you're doing workflow development, to make sure that we pay attention to the top right corner and the different, the data type. So now you can see that I should be getting matches. I have the vector. Okay. So the next piece is to be able to extract out the content. So in order to extract the content, I have to use a couple of cards. So what I would do is I would do object get, and then I'm extracting out the content here based on matches. The next piece is to extract out all of the different elements within that. So let me go ahead and use a pluck. So this will actually give me a list. So what I can do is I can do a pluck. Given a list of objects, and I would set that, I want to be able to extract out the particular value. Right? Once I've gotten those values, it would be a list of text. And so I can take all of that and combine it with a separator. So that would be a list to text separator. So you see, we have a simple way to take that list of text, and I'm going to do a new line character. So now I need to prepare the payload for my chat completion API. So there are two aspects. One is an object construct. So I'm going to provide the role, user, and then another object construct for the role of system. So we have to create what is needed for each of these. Now for the user, I'm going to go ahead and set the content to be text. I'll take the text compose. So this text is the text that comes out of the vector database search. I augment it with the base query. And the base query is based on summarizing the group name. So let me go ahead and just drag that over. You notice if you pin that first card, makes it easy to drag and drop values from there. So now I've got the text and the group name. So let me go ahead and put that in for the content here. The next aspect is, what do I do for the system? This is where I'm going to provide it the instruction. So you are a Q&A bot and don't hallucinate. So we'll put that in with the text compose card. So you notice now that when I drag and drop it, it uses the same name as what I had put there. But what I could do is I could rename that. So I go ahead and make that content, because that's what the chat completion API would expect. Okay, so you notice I have role content, right? One for the user, one for the system. So this gives me one object and this gives me another object. If I look at what the chat completion API requires, it has the messages, which needs to be a list of objects, right? So let me go ahead, pick my model here. My model will be GPT-4. And I have a list of objects. So in order to create a list of objects, what I need to do is take a list and construct it. And I will take one object for my user and one object for my system, right? And I will take that list of objects, matches list of objects, and put it into messages. In this particular case, I don't need all of the other parameters, so I will take that out. And I'll save it. So with that, what we have done end to end is we have actually taken a group name, we have created a base query, got the embeddings from OpenAI, and then we have used that to search against Pinecone database. It's a vector database search. We get the results, we do some manipulation to create the inputs into the chat completion API. And at that point, it returns the value. So let me go ahead and run this so that we can see the execution. So it's got Clary Advanced User Group. So the object construct, we go over to OpenAI, and it generates the embeddings, goes to Pinecone, searches, and then over here, when it comes out, if you can see over here, we do have from the search that it has a lot of unrelated information. But once we send it through the chat completion API, we're getting just the information that we expect. So Max, that's the basic model here. So let me go ahead and see if I can give Crowdcast one more attempt to share my screen here. So remember that modeling step that I talked about? Let me give you a quick insight of what that looks like. So I install some packages, right? And then what we do is we take all of this data that we have and we load it in. So that data looks like this. And then what we're doing is we're using an encoding, right? And then splitting up the text a little bit. And the idea is that at the end, we go ahead and chunk it, right? So this chunk size is a hyperparameter tuning aspect. And then we go ahead and go to OpenAI and we say, here's our input data, give me the vector. I take that vector And what, you can actually look for the small data set that I have. I printed out the similarity between these. So you can see that there's some similar data with a, this is a cosine value of those two vectors, right? But what I do then is I go ahead and insert those into Pinecone database. Because I use that text embedding 3 small, the dimension is 1536. There's a text embedding 3 large, which has a different dimension, a much larger one. So at that point, what I do is I've put it all into this Pinecone index. And we run some samples to tune the model. This aspect is the modeling. So, based on this, you go and you update your hyperparameters, and you can go ahead and test it out. But in runtime, this is what we would implement in Okta workflows, where we get this group name dynamically, and then we perform these operations through Okta workflows. Okay, so hopefully that helped.
Yes, thank you, Ajay. So we don't, you stop sharing, right? And we also, correct, right?
Stop sharing, yes.
Yeah, okay.
In this little time that we had together, we have gone ahead and actually implemented a retrieval-augmented generative AI model in real time with Okta workflows. That's the power of the Okta workflow platform.
Very cool, very cool. And again, I know some folks had some difficulties with the video, so you can always watch a replay and then, if you missed anything. But Ajay, there's one question, and I'm gonna read it to you. So Rob is asking, what readings do you recommend for RAG and Pinecone vectors for beginners?
There's a ton of content out there. I would say there are some very good YouTube videos if you just Google it. One of the interesting things is what I've demonstrated here is a base retrieval-augmented generative AI model. There are extensions of this. So for example, let's say you want to put some guardrails around the response, right? So then there's a guardrail RAG pattern. And so there are different design patterns that essentially build on top of this base pattern. So I wanted to just give you an introduction here. You can go ahead, we'll post a lot of these artifacts along with the recording so that you can then use those YouTube videos and then look at it in the context of what we have discussed today.
Perfect. And then maybe Ajay, maybe we can send in the message that I sent tomorrow. Maybe we can include 1 or 2 links
sure.
to those resources. Very good. All right, I mark the question as answered. Yeah, let us know, folks, if you have any other questions. Well, Ajay, I don't see any questions. But thank you again for coming. For coming on Crowdcast, and I know we said it last time. We'll definitely have you back again in the future.
Yeah, sorry about the little technical glitches here as I went through today.
No worries. No worries. But yeah, as I said, yeah, if there was some audio or video, you can always watch a replay. Again, once we end the session, the replay will be available on Crowdcast, and then tomorrow we'll post this on YouTube. But again, I don't see any questions. So folks, thank you so much for joining us today. And Ajay, thank you again for hosting a wonderful session. And then we'll see you next time. Bye-bye.
Thank you.